We looked at the NPE as a great place to kick off one image for the company. It brought us all together for one conversation to deliver all of the solutions and systems that we have on display here today. In the last 2 years, we have done more innovation than we have totally in the last 10. But we've brought all of what we have under one roof to make easy access to our technologies for our customers.
We have 14 work cells around this booth, and every one of them has a piece of innovation in it that makes it really special. We have all the pieces here to put together something from pellet to gate. We've really emphasized innovation for the last couple of years. Part of bringing us all together has allowed us to have a lot of fertile cross-pollination between different types of development, whether it be a hot runner or a machine or a blow machine. They all have common parts to it, and we're able to bring that together.
You see the level of technology that we possess within our company. Injection molding, blow molding, PET preforms, co-injection, multi-layer, multi-material, hot runners, mold technologies, process control, auxiliary extrusion, and fluid technologies. We have more under our roof than anyone else does within the industry. Two of my favorites that sit on the booth because they demonstrate the power of what we've been able to do. In 13 months, we've been able to turn around a PET preform machine that's operating at industry standards with the potential to get better.
So this is a complex interaction of a whole bunch of different processes to produce what is really a very simple part in a preform. But we had to take a very demanding application for injection, which is high volume of throughput, in a very consistent and homogeneous way, distribute it into up to 144 cavities, and do that in cycle times less than 7 seconds. And we can do that now under one roof, under one name in Milacron.
And then Klear Can, which is really another swing at the fence for us in terms of innovation.
So the Klear Can has been developed by Milacron. It's a multi-layer can designed to replace tin cans in the marketplace for attractive foods such as fruit and vegetables. The brand owners who I've been working with are very interested in the possibility of being able to show their consumers the quality of the food at the point of purchase. So when they're actually in the supermarket, they can see the quality, so they can be sure what they're getting for their money is good quality food for their family to eat.
We then took it from micro to macro to show what we could do now with a much heavier part, which is a 5-gallon pail. And in this case, it's not so much about how thin can you make the layer on the inside, it's about how thick can we make the layer on the inside. We did not compromise the cycle time one iota. As a matter of fact, we bumped it up in performance. So that 5-gallon pail system is molding at 14-second cycles or less. Another example of multiple materials is taking a thermoplastic together with a thermoset. And in this case, we are injecting polycarbonate as the core material, and we're using an integrated rotary platen to inject over top liquid silicone rubber on our e-multi system. So we've taken what traditionally is a very difficult process and integrated it into a single system. And on the blow molding side, this one is almost non-recognizable in the cell, but it was really, really advantageous when we did it. We took our injection blow machine, we've now made it class leading in terms of energy efficiency by making it a hybrid machine and adding electric functions to it. And then we've taken the Moldmaster technology and we've embedded it into the machine. We put together this work cell on the floor that you can see just behind the front reception, which is taking 3D printing, which everybody knows how big that's getting, and seeing how that fits with injection molding. So in this case, what we're doing is we're actually printing the cores and cavities, and we're taking those cores and cavities, we're putting them into a standard DME mud mold base, and molding them in a 17-ton RoboShot. So now we can make 500 parts in a day for prototyping, and these are perfectly functional. They're made and used in the normal plastics processing way.
And there's more change to come. And the change that we will go through the future is really going to be driven by the requirements and needs of our customers.
We hope that when you look around the show and you see these systems, you can see what we've done to try and satisfy the customer needs we see out there, whether it be a preform or a bucket or a bottle or a can. It's all really driven out of the customer, or the voice of the customer.